Hey guys, this is your exponential growth and decay application practice. So if you remember yesterday we talked about simple interest and compound interest. And if you recall, simple interest looked linear, right? It looked like, when we represented it with an equation, it looked like y equals mx plus b. And if you recall, compound interest looked exponential. So we represented that with our exponential equation. So all of these situations that you are going to be practicing today in this worksheet are going to be that compound interest. They're going to look exponential. You're either going to have interest that you're earning, that's growing, or you're going to have depreciation. So I'm going to do a few examples with you here. So we're going to scroll down and I'm just going to remind you of our exponential equation. So we have y equals a times b to the x. And just remember that a is our initial value or our starting value. And remember that the b represents the growth or the multiplier. All right, so let's take a look at number 5. It says $28,000 is invested at a rate of 4% compounded annually. So that just means it earns 4% each year at the end of each year. So we're going to write our equation. All right, so let's fill in the pieces. I know that my initial value is going to be 28,000, but let me take a look at what my multiplier is going to be. So I know that this is going to grow by 4%, so it's going to increase by 4%. So the first thing I need to do is convert that percent into a decimal, right? So I'm just going to move my decimal 2 places to the left. So this becomes 0.04, okay? Now, this account is going to, 28,000 is invested and you're going to earn 4% more every year, okay? So I need to show, if I'm showing that the account is earning more, that I'm going to have an increase of 4%. Remember that my multiplier is going to have to be 1.04, okay? That 1 accounts for the original $28,000, okay? If I just multiplied by 0.04, then the amount of money in my account would decrease, right? And I need to show that it's increasing. So that 1 is going to account for the original $28,000. The 0.04 is going to account for that 4% increase on top of that original money. So if I'm writing my equation, my original amount is 28,000. And then my multiplier is 1.04. Remember, anytime we have exponential growth, our multiplier is a number bigger than 1. Okay? Anytime we have exponential decay, our multiplier is going to be between 0 and 1. And we'll see an example of that in a little bit. All right, now that we have our equation, we are going to find the balance in this account after 5 years. So we are just going to take our equation and we need to substitute 5 in for x. All right, and now what I'm going to do is I'm going to put this in my calculator. And the thing that you have to remember is that your order of operations, right? We need to do exponents before we do multiplication. So the first thing I'm going to have to do is take 1.04 and raise it to the 5th power. And then I have to take that answer and multiply it by my $28,000. All right, and when I do that, I get $34,066, and then I'm going to round it to the hundreds place, right? Because we're talking about money here. So in 28 cents there. All right. So my initial amount invested was 28,000. I earned 4% every year. After 4 years, that account now has $34,066.28. Okay. Let's try another one. All right, let's take a look at number 6. This one says $7,000 invested at a rate of 3% compounded quarterly. Okay, now instead of us getting the money at the end of the year, we're going to get 3% over the course of a year, but we're going to get a little bit of it every quarter, right? So there's 4 quarters in a year. So every 3 months, we're going to get part of that 3%. Okay, so we know our initial value is going to be that $7,000, but now let's take a look at what our multiplier is going to be. Okay, so we have 3%. That's how much it would, if we were compounding annually, we get 3% every year, right? But we get that broken out into 4 quarters. So I'm going to take my 3% and I'm going to just divide it by 4 because I'm going to get that 4 times a year, right? So when I do that, so if I take that 3% and divide it by 4, right, we get 0.75%, okay? So instead of getting 3% at the end of the year, every quarter, so 4 times a year, I'm just going to get 75% of that 3%, okay? Now this is still written as a percent, so I'm gonna need to change this into a decimal, right? How do I do that? I move my decimal 2 places to the left, okay? Which becomes, so if I move this 2 places to the left, 0.0075. All right. Are you with me so far? And then, right, now I am going to be earning this interest, right? So I'm going to be getting more money. So to show that money is going to be increasing, remember we have to put a 1 in front of this so that we account for that original $7,000 that was invested. So our multiplier here is going to be 1.0075. All right. So now that I have my starting value and my multiplier, I'm going to put this into the equation. All right, to the x power. Okay, that's my equation. All right, now, if we're going to find the balance after 10 years, all right, we need to substitute something in for x, but we need to be careful here. So I'm just going to rewrite my equation. Okay, now let's think about this. If I wanted to know how much money I would have after 1 year, I would have to put in a 4 for x, right? Because I'm getting that 75% or that 75% interest 4 times a year, right? So every year I'd get that 4 times. So if it was 1 year, I would put a 4 in for x. But now I want to know after 10 years, right? So if it's going to be compounded 4 times a year for 10 years, how many times are we going to get that interest? 40 times. Okay, so I'm going to take this, put it in my calculator. Again, you have to do the exponents first. So you're going to take your 1.0075, raise it to the 40th power, and then take that answer and multiply it by $7,000. All right, and then we end up getting $9,438, and remember we want to make sure we round to the hundreds here, 44 cents. Okay. So we did a exponential growth that was compounded annually. We did an exponential growth that was compounded quarterly. Now let's take a look at one that is exponential decay. So let's go down to number 9. It says the population of a town is 18,000 and it is decreasing at a rate of 2% per year. And then they're going to ask us, what is the value after 6 years? So we're going to write our exponential decay function. All right, so let's see, we know our starting value, $18,000. Now we have to figure out our multiplier, right? So if this is now, we have a decreasing problem here, right? So remember when we have exponential decay, our multiplier is going to be between 0 and 1. So let's think about this. If this population is losing 2% of the population every year, what percent of the population is still there? Well, if 2% are gone, 98% of the population is still there. Okay, so we still have 98% of the population there. What is that as a decimal? Remove it, move it over 2 places. So we get 0.98. Okay, that's our multiplier. So now we have our start and our multiplier. So if I'm writing this out, starting value times my multiplier to the x power. All right, remember in the last 2 problems we did, that was growth, so our multiplier was greater than 1. This time we have decay. So we're going to take away the part that of the population we're losing. We're losing 2%, so what are we really having left over? We're having 98% of our population left over, so we have to multiply by 98% as a multiplier, so by 0.98. So now, let's substitute in our 6 for our years. All right, let's figure out after 6 years how much of our population will still be there. So again, do your exponents first. Take 0.98, raise it to the x power. Take that number and multiply by 18,000. All right, when we do that, we end up getting 15,945. I'm going to round it to the whole number here because we're talking about a population, right? We're talking about people. Okay, so after 6 years, our population went from 18,000 to 15,945. All right, good luck working out the rest of these. Have a good day.